This video will explain the functions of the robot transport controller that controls the robots found under the Work, Advanced, and Transport tabs. As this video is a continuation of the How to Control Robots Using a Controller Part 1, it is recommended that How to Control Robots Using a Controller Part 1 is watched before this video. First, we will explain the Work tab. This tab defines the settings when a work task is allocated by a work statement. To explain the properties, we will add a work statement. Go to the Process tab, Editor, click Processes, and right-click the Sync Process label. With Transport in selected, add a work statement from statement indicated by the 9 circles icon. Click the added work. From the Statement Properties window, change Controller to Robot Transport Controller. Here, we will explain each property. Motion type defines the work details of a work task. When set to hold, the robot stops for the amount of time the process takes. When set to up-down, the robot arm moves up and down. When set to rectangle, the robot arm moves as though it is drawing a rectangle. When set to custom routine, the robot program specified under routine name is executed. Now we will add sequence 1 and confirm its operation. Click the Program tab and select the generic articulated robot on the 3D world. On the Program Editor window, click Add Sequence indicated by the plus sign and add sequence 1. Confirm that Jog under Manipulation is selected, drag the gripper of the generic articulated robot to move its position, and click Point-to-Point Motion Statement. Change its position and add Point-to-Point Motion Statement. When we play the simulation, we can see that the sequence 1 we set earlier is running. When no program is specified, the robot will stop for the amount of time the process takes. The time it takes for the robot arm to move to the work position frame is included in the process time, regardless of the setting for motion type. On the servo track, the robot movement is not included in the process time. Motion distance defines the work task movement distance. Set this property when up-down or rectangle is selected for the motion type. When motion type is set to up-down, set the distance from the lowest point to the highest point, and when set to rectangle, set the length of the rectangle drawn. Motion elevation defines the work position frame z-axis offset of the allocated work task process. It will be the position where the robot will operate. Set this property when anything other than custom routine is selected as the motion type. The work position frame can be set in the statement properties of the work statement. Motion loops defines how many times the work set in motion type occurs during one work task. Set this property when up-down or rectangle is selected as the motion type. The amount of time it takes to do one operation is automatically scaled to match the process time set in the work statement. Therefore, a low number indicates a slower operation, and a higher number indicates a faster operation. Scale cycle time is a function that scales the routine program operation time so that it fits within the process time defined in the work statement. Set this property when custom routine is selected as the motion type. As only point-to-point motion statements and linear motion statements are scaled, other operation times take time separately to the process time. For example, with a delay 5 seconds statement, 5 seconds will be added to the process time to become the total program operation time. Tool defines the tools used by the robot for the work task. When set to use current, it will continue to use the tool used before. If a tool has not been used, the work task will be performed without using a tool. When set to tool name, set a keyword when searching for a tool to be used, and decide which tool to use. Setting a keyword here requires a character string of 4 or more characters. The character string set here only needs to partially match the name of the tool to be used for it to be searched for. A tool is used by searching for a name that matches the keyword inputted in toolname by searching from the 3D world. When there are multiple tools that satisfy the conditions, the tool closest to the controller is used. If the name of the tool set does not exist, or if the tool is in an unreachable location, an error is outputted, and the robot stops moving. If the robot has used a tool in the previous task and will use a separate tool for the work task, it will return the tool previously used to its original position, and then start the work task. If the robot has used a tool in the previous task and will use the same tool for the work task, it will start the work task directly. Go to the eCatalog window, Models by Type, Robot Tools, Visual Components, and drag and drop a generic 3-jaw gripper onto the 3D world. With generic 3-jaw gripper selected, go to the Component Properties window, the Default tab, and change the name to Gripper 2. Click the Robot Transport Controller, and on the Component Properties window, go to the Work tab, check that tool is toolname, and toolname is Gripper 2. Then play the simulation. We can see that a tool is being used while the work task is in operation. When no tool is selected, the work task will be performed without using a tool. When a tool is used in the previous task, the work task starts after the tool being used has returned to its original position. Priority defines the priority level of the work task. This value can be set between 1 and 100. The smaller the value, the higher the priority. If the priority of 2 or more work tasks are the same, processing occurs based on the FIFO, first in first out, method. Transport tasks have the same priority property. The priority setting of work tasks and transport tasks is shared. Here, we can see the simulation of 2 different programs. On both screens, there are 2 transport links and 1 work statement. On the left, all of the priority are set to 1, and the tasks are being executed in order. On the right, the transport link between feeder 1 and sink 1 has a priority of 1, the transport link between feeder 2 and sink 2 has a priority of 2, and the robot transport controller work has a priority of 3. This means that on the right, the transport task between feeder 1 and sink 1 is prioritized, and work tasks are executed only when there are no other tasks. This concludes the explanation of the Work tab. Next, this section will explain the Advanced tab. When the Use Gripper Signals checkbox is selected, the opening and closing of the gripper is controlled through the signal of the connected gripper. Grasp Signal Port Index defines the output signal port number of the robot connected automatically by the controller grasp signal when a robot is connected to a controller. Grasp Container Name defines the container behavior name in the robot component used when the arm picks up a product. The name of the container behavior can be specified by going to the Modeling tab, Component Graph window, and clicking the plus icon to the left of Behaviors, and specifying a name to be displayed. Tool Interface Name defines the interface behavior name of the robot component for connecting the tool to the end of the robot arm. When these two are left blank, or if a specified name behavior cannot be found, a default value is used. When no value needs to be set here, this can be left blank. The name of the interface behavior can be specified by going to the Modeling tab, Component Graph window, and clicking the plus icon to the left of Link 1, and specifying a name to be displayed. This concludes the explanation of the Advanced tab. This section will explain the Transport tab. The Transport tab defines the settings of the robot when it is allocated a transport task. Capacity sets the number of products that can be held by a connected robot at the time it is transporting. This setting is initially set to 1, and requires setting to 2 when using the double gripper. Multi-pick strategy defines the rules when there are multiple transport sources or transport destinations for a transport task. When set to 1-to-1, the robot loads a product from one process and unloads it to another process. When set to 1-to-many, the robot loads a product from one process and unloads it to multiple processes. When set to many-to-one, the robot loads a product from multiple processes and unloads it to one process. When set to many-to-many, the robot loads a product from multiple processes and unloads it to multiple processes. Transported products are unloaded in the order of how they were loaded based on the FIFO, first in first out, method. This concludes the explanation of the Transport tab. This concludes our explanation on the functions of the Robot Transport Controller under the Work, Advanced, and Transport tabs. Thank you for watching.